Okay, so our first question is the first part of number one, actually, is if we're trying to do a trapezoidal approximation for this integral, what's the problem? Well, you immediately run into the problem because you know the graph, of course, looks something like this, okay? And let's say that, one on this axis is here, and one on the y-axis is here, so there's your point 1, 1. So we're actually looking for the region between here and here. Well, we can easily divide everything into trapezoids, many as you like, except this very last trapezoid, whatever this number is, well, we can certainly evaluate the function, but it's undefined for 0, so our first trapezoid only one graph altitude can be found, since 1 over 0 is undefined. And of course, your first trapezoid would have to run from 0 to whatever, right? Okay? So, anybody get around that and actually calculate this area, or come to the conclusion that the area is undefined because you don't have a finite area under the curve?
Could you not just take the integral?
I'm sorry?
Could you not just take the integral?
Well, if you try to take the integral, and we're just dealing with the trapezoidal graph right now to see what we might do. But if you try to take the integral, you run into the same problem. You get this integral from 0 to 1, 1 over x dx would equal the natural log of x, evaluated between 0 and 1, which would be the natural log of 1, which is 0, minus the natural log of 0, which is undefined. Right? So, doesn't do you any good. Okay, well, to see what we might do, let's just take the integral from 0 to 1. And I'm using a little different y scale, and I'm just kind of depicting the thing. But I want to, okay, subdivide into n equal increments and ignore the first trapezoid. At least for now. Okay? So that means, okay, we're going to divide this into n equal parts, whatever n is. And we got some first trapezoid that we just don't even bother with. So we got these trapezoids here. Okay? So, well, the x-coordinate here, of course, is 0. What's the x-coordinate at the first point? If we divide the interval from 0 to 1 into n increments, how wide is each interval?
N.
It's what?
N.
Well, if it's n, I mean, right here I've got like close to 10 intervals, right? So the width of the interval is clearly not 10, is it?
No, so is it the 1 minus 0 over n thing again?
Yeah, it'd be 1 minus 0 over n, okay? Which is just 1 over n, right?
Mm-hmm.
Okay? So, each interval has width 1 over n. You could say 1 minus 0 over n equals 1 over n. Okay, so the x coordinates at which you have to evaluate this thing are the x coordinates of your partition are 0, right? And what's in the coordinate of the first point at which you need to evaluate?
X naught.
I'm sorry?
Is that X naught?
No, this would be x naught, and that'd be x sub n, but we want to be specific because we have a specific interval width now. So how wide is this interval?
It's 1 over n.
Okay, and it's 0 here, so what's the coordinate here?
X sub 1, would that be it?
No, the width of this thing, say the width of this thing is w, okay? Then this point is 0. How far do you have to move to get to here?
Okay, W.
So what's the coordinate?
Would be 1 over n.
We're not talking about n. Width is w.
Okay, so W.
The width would be, yeah, it'd be w, right?
Mm-hmm.
And what would the coordinate of this point be?
Like 2W?
Yeah. Now we got a pattern, maybe. What do you think this one is?
Yeah, so 3W.
Yeah, very good. Okay? Now, if w is 1 over n, then this is 1 over n, which I think you tried to say a minute ago. Okay? Wanted to be clear. And this would be what?
2 over n.
Yeah. So, and of course, n over n, which is 1, right? So if we ignore the first interval, we don't have to evaluate it at 0, which is a good thing because we can't. But now we have to evaluate it at all these points, right? Okay? So the corresponding graph altitudes are what? Well, the first one is undefined. What's the second one? The function is 1 over x, right? So what's the x value? 1 over n. So what's the graph altitude corresponding to x equals 1 over n?
Would it just be n?
Yeah.
Okay.
It's 1 divided by 1 over n, right? Which is 1 times n over 1, which is n, right? So the first one would be n. The second one would be what?
Would be n over 2, would it?
Well, you're going to plug this in for the x value.
Yeah.
You're going to get what?
1 over 2 over n.
Which is?
Would that just be n again?
Okay. How do we do this? It's 1 times n over 2.
So it would just be n over 2?
Now take a stab. What's the third one going to be?
Yeah, it'd be n over 3.
Yeah. And the last one would be n over n. Okay? Because reciprocal of n over n is n over n. Okay? And of course that's 1. Okay, so the areas would be what? Well, it's a little bit complicated to do the areas of the trapezoids. Okay? So I'm going to say using a left-handed Riemann approximation, which is not as accurate, but since we're going to let n approach infinity, it's not going to matter. Okay? We use a left-hand Riemann approximation, so we just use the left-hand altitude as instead of the average graph altitude. So we just get a rectangle. First rectangle is going to have height n. What's its area going to be?
Would be 5 times 1 over n.
Well, it's the graph altitude that we're using, which is this,
Yeah.
multiplied by the width, right?
Yeah.
Well, the altitude of the first one would be n. And what's the width?
Just 1 over n.
Yeah. And then what would the next one be?
N over 2 times 1 over n.
N over 2 times 1 over n. N over 3 times 1 over n, etc., up to n over n times 1 over n. Okay? And of course that would be 1, 1/2, 1/3, all the way down to 1 over n, right? So the total area would be the sum of all these. Okay? So I can say and I'm not going to say trapezoids, and I'll say interval approximation ignoring the first interval is what? Well, we just add these up, right? That would be 1 plus 1/2 plus 1/3 all the way up to 1 over n. Okay? Now, as n goes to infinity, you get the entire area except for just a small sliver, right? Okay? So, we express that as the sum. Okay? It's well known and easily